Hello class, today we'll be talking about 5.2, trigonometric functions. So in this section, we're going to look at trigonometric functions, quadrantal angles, reciprocal identities, sine and ranges of function values, Pythagorean identities, and we'll look at quotient identities. So trigonometric functions. It says let x, y be a point other be a point other than the origin on the terminal side of the angle theta in standard position. The distance from the point of the origin is r is equal to the square root of x squared plus y squared. All right. So basically, what you're saying, you're finding your hypotenuse. So you're actually finding this point here. So you're finding r. So basically, you're given a point x, y, which your x is your what? Your horizontal axis, and your y is your vertical axis. So let's look. So when we look at the trigonometric functions, we have 6 trig functions. We have sine theta is equal to y over r. We have cosine theta, which is equal to x over r. We have tangent theta is equal to y over x, where x is not equal to 0. Then we have cosecant theta, which is equal to r over y, which is the reciprocal function of sine, where y is not equal to 0. Then we have secant of theta is equal to r over x, which is the reciprocal function of cosine, so where x is not equal to 0. Then we have cotangent of theta is equal to x over y, where y is not equal to 0, which cotangent is the reciprocal function of tangent. So basically we have y and we have your r, which are, that's going to be your hypotenuse. And we'll talk more about that when we talk about regular triangles. All right. So now it says finding the function values of an angle. So in this problem, it says the terminal side of the angle in standard position passes through the point 8, 15. It says find the values of the 6 trig functions. All right, so let's look at what we got. So I already know my x is equal to 8 and my y is equal to 15 because it's xy. So basically I have r is equal to the square root of 8 squared plus 15 squared. Because remember, they gave us r is equal to the square root of x squared plus y squared. So we have r is equal to the square root of 64 plus 225. So r is equal to the square root, and we need to put this in the calculator. It'll be what? 289. And the square root of 289 is 17. So now that you have your r, you can go ahead and find your 6 trig functions. So we have sine theta, cosine theta, tangent theta. So I will find the first 3 first. So we know that sine theta is what? Y over r. So it'll be what? It'll be 15 over 17. Then we have cosine theta, which is x over r. So it'll be 8 over 17. Then we have tangent, which is what? Y over x. So it'll just be what? 15 over 8. Now, then you can go ahead and just do the what? The reciprocal functions. So cosecant of theta is what? 17 over 15. Secant of theta is equal to 17 over 8. And then we have cotangent of theta is equal to what? 8 over 15. So this is your 6 trig functions. Now, I always say do your 3 main ones, which is sine, cosine, tangent. Then do the reciprocal ones beside it, because all you got to do is flip it. Make sure if you have any questions, you let me know. So now let's look at this question here. So in this question, it gives me what? It gives me a point of -3, -4. So if both x and y are negative, that means we're in the third quadrant. All right? So let's go ahead. So I know that x is equal to -3, y is equal to -4. So when I do my r, it'll be r is equal to the square root of parentheses -3 squared plus parentheses -4 squared. So r is just equal to the square root of 9 plus 16. So r is just equal to the square root of 25. So r is equal to 5. Now, since we know r and we know x and y, we can go ahead and write our stuff. So we do the sine of theta. We do cosine of theta. We do tangent of theta. Once you find these 3, you can find the other 3 easily. So we know that sine is what? Y over r, so it'd be -4 over what? 5. Then we got x, then we got cosine being x over y, x over r, so it'd be -3 over 5. Then we have tangent being what? Y over r, so it'd be -4, y over x. So it'd be -4 over -3, which that'll just be positive 4/3. All right? So now we got cosecant of theta. Then we got secant of theta. And then we got cotangent of theta. And all we got to do is flip it. So that'd be -5 over 4. Go ahead and erase that. All right. This would be negative what? 5 over 3. And this would be 3 over 4. So just keep in mind that you all you got to do, if you know the first 3, which is sine, cosine, tangent, then you'll know the rest of them. So don't make it more complicated by switching stuff up. All right, here we go, example of this one. So let's look at this. So it says find the 6 trig functions of the values of the angle theta in standard position if the terminal side of theta is defined by x plus 2y equal to 0, where x is greater than or equal to 0. So we're going to manipulate this a little bit and change it around. So I got x plus 2y is equal to 0. So basically I got 2y is equal to -x, and I got y is equal to change this. I got 2 is equal to -x over y. Now, me personally, I don't want the x over y negative. Now, me personally, I'm gonna go ahead and change some things. So I can take the reciprocal of both sides and make it y over x. But the first thing I'm gonna do first is do this. I'm gonna make it -2 is equal to x over y. All right? I just did what? Divided the -1 over. Now I'm going to flip both sides. So therefore I got y over x is equal to 1 over -2. So basically y over x is equal to negative 1/2, right? All right, so everybody got it. So if you got any questions about this, so what I did was I just solved for y over x. All right. So, and you could have did it a different way. You could have moved the the 2y on the other side. You could have did all that. You could have, or you could have moved. You could have moved anything. So just keep in mind. So now I know what y over x is. That is equal to what? Tangent theta. Right? That's equal to tangent theta. So let's actually do this. So basically we have x over y. So we have now, to understand this, we know that the x is greater than or equal to 0. So we know the negative goes with the what? Y. So we have r is equal to the square root of 2 squared plus negative 1 squared. So r is equal to the square root of 5, right? Because it's gonna give you 4 plus 1, which will give you 5. Now we found that, we can go and find our other trig function. We already have one, which is this one. We already know this one. Now we technically have 2, right? Because we know that that one is equal to what? Cotangent theta. X over y is cotangent theta, right? So we got 2 for the price of 1, right? So now we just need to find our sine theta, cosine theta, all right? And then the reciprocal functions for them, which would be what? Cosecant theta and what? Secant theta. So we know we have r. Now, we got y, which y in this case was what? Negative 1. So we got negative 1 over the square root of 5. Now, we have to rationalize this. Now, to rationalize this, for people who may not know, if I got negative 1 over the square root of 5, I have to multiply by the square root of 5 over the square root of 5. So that's going to give me negative square root of 5 all over 5. All right, so it'll be negative square root of 5 all over 5. And then we're going to do the same token here, so we're going to have 2 over the square root of 5, which that's just going to give me 2 times the square root of 5 over 5. Now, I'll always do the first step because when I do the reciprocal, it's just easy to just say that this is just going to be this negative square root of 5. And this one right here is going to be what? The square root of 5 over 2. If you have any questions, make sure you ask me, all right, about rationalizing any of that stuff. So basically, you got everything that you need. You got all 6 trig functions. You got 2 for just solving out the first parts. And then now, you got the rest. All right. Now, let's look at this. All right. It says conditions for undefined function values. It says identify the terminal side of the quadrantal angle. If the terminal side of the quadrantal angle lies along the y-axis, then the tangent and the secant are undefined. If the terminal side of the quadrantal angle lies on the x-axis, then the cotangent and cosecant is undefined. All right? Now, let's look at what we have. So if I got the sine of 0, all right, the sine of 0 is 0. The sine of 90 is 1. The sine of 180 is 0. The sine of 270 is -1. And the sine of 360 is 0. And you go through this, you got the cosine of 0 is 1. The cosine of 90 is 0. The cosine of 180 is -1. The cosine of 270 is 0. And the cosine of 360 is 1. Now the tangent of 0 is 0. The tangent of 90 is what? Undefined. Because remember, the cosine of 0 is 0. Now if the cosine, remember, when we deal with this, remember this sine represents y and cosine represents x. And remember, tangent is what? Y over x. Cotangent is what? X over y, right? So basically, we have stipulations that tell us that we can't have, all right, we can't have 0 in the denominators, right? So in this case, if the cosine of 90 is 0, then 0 will be in the denominator of tangent. Therefore, it would be undefined. What about secant? Think about secant. Secant is what? If you think about it, it's just the reciprocal of cosine. So it'll be just 1 over x. So when cosine is 0, secant is undefined. And the same with cosecant. It'll be 1 over y. So when sine is 0, cosecant would be undefined. So let's look at the reciprocal identities. So for all angles, theta, for which both functions are defined, sine theta is equal to 1 over cosecant theta, where cosecant theta is equal to 1 over sine theta, because they're reciprocal. Cosine theta is equal to 1 over secant theta, which is just, if you were to rewrite it, it'd be secant theta is equal to what? 1 over cosine theta. And you have tangent theta is equal to 1 over cotangent theta. Then you got cotangent theta is equal to 1 over tangent theta. So let's look at an example of this. So it says find cosine theta given that secant theta is equal to 5 over 3. Now, of course, you're probably looking like, okay, this is pretty easy, right? Okay, let's look at what we got. Now, honestly, you know that the reciprocal functions, all you got to do is really flip it. But I'm going to show you a little bit of the math behind it. How they actually flip this. So, if I know that secant theta is equal to 5 over 3, then I know that what? Cosine of theta is equal to 1 over 5 over 3, which just equals what? 3 over 5. So make sure if you have any questions about this, you make sure you ask about it. Now let's look at one that isn't the easiest. So with this one, we know we got to flip it. So we already know that sine theta is equal to -2 over what? The square root of 12. Now with this one, you have to simplify. Now, to simplify this one, we have to look at it. All right, so now me personally, what I like to do is I want to go ahead and reduce the square root of 12. Now, the square root of 12 can be reduced into what? A perfect square of 4 times 3, which is equal to the square root of 4 times what? The square root of 3, which to reduce that is just 2 times the square root of 3. So I just reduced the radical. So basically, this is nothing but what? -2 over 2 times the square root of 3. Therefore, I can reduce the what? 2's. So it'll be -1 over the square root of 3. Then when I rationalize, so I'm going to get what? Negative square root of 3 over what? 3. When I rationalize. So keep in mind, see, I did some side work here. So that's my little side work. So I put SW just to make sure that I can make this easy as possible. So let's look at this. So basically, it just tells you which one is positive, which one is negative in the certain quadrant. All of them are positive in the first quadrant. Sine and cosecant is positive in the second quadrant because that's when your y's are positive. Everything else is negative. In the third quadrant, only tangent and cotangent are positive because x and y are negative. So when you divide them, they do what? Make a positive. In quadrant 4, only cosine and secant are positive because that's when the x values are positive. Everything else is negative. So basically what I just told you a minute ago, but this is just a representation of it looking at the actual quadrants themselves. The other part was just a thing telling you what quadrant. This right here is just showing you what quadrant. So just make sure you look at this for a reference. So here we're looking at, it says identify the quadrant or possible quadrants of any angle theta that satisfy the given conditions. So the first thing we look at, if we basically have sine being positive. All right. So what quadrants is sine positive? Sine is positive in what? Quadrant 1 and quadrant 2. But it tells us that what? It also gives us another stipulation that tangent is what? Negative. Now to make tangent negative, then we have to have a what? Negative x. So therefore, we should be in quadrant what? 2. So this one is in quadrant 2. All right, so just keep that in mind. So this one lies in quadrant 2. So let's look at this one. This one we have cosine is what? Negative, and secant is negative. Now remember, cosine and secant are what? Reciprocal functions. So when one negative, the other is negative. So we have a possibility of it being in what? This one can be in what? Quadrant 2, quadrant 3. So it could be in quadrant 2 or quadrant 3. That's the possible ones that this can be in. Because both of them are x values. That's when x is negative in quadrant 2 and quadrant 3. So let's look at our next example. So it says ranges of trigonometric functions. So sine and cosine, y such that the absolute value of y is less than or equal to 1, where the range would be from what? -1 to +1. Tangent of theta and cosangent of theta, y is such that y is a real number, is from -infinity to +infinity. Secant theta, cosecant theta, y such that y, the absolute value of y is greater than or equal to 1. We have what? From -infinity to -1, bracket, union from 1 to infinity. So these are your ranges. So just looking at these right here, and I left the actual thing up just to kind of, it says decide whether each statement is possible or impossible. So if I got the sine theta of 2.5, now 2.5 is not in the range of -1 to +1. So that's impossible. Now tangent B for tangent theta equal to 110.47, we know we have all real numbers, so that would be a possible solution. Now we got secant theta is equal to what? 0.6. Now, if we're talking about, we have to look at in reference of what? Cosine. Right? So when we looked at that past one, that one that we just looked at for the ranges, we did what? We said that secant is what? Is from negative infinity to what? -1, and from 1 to what? Infinity. So it does not include anything in between -1 and 1, right? So it doesn't include none of the stuff in between. So therefore, it's impossible to have. So you'll get undefined, basically. So let's look at this problem here. So it says, suppose an angle in quadrant 2 and sine is equal to what? 2/3. Find the value of the other five trig functions. Choose any point on the terminal side of the angle. All right, so we already know what y and r is because they gave a sine. So let's look at this. So therefore, now the purpose of telling me what quadrant it is in is basically to say which one is negative and which one is positive, basically. Now, we already know in quadrant 2, cosine is negative. Secant is negative, and tangent and cotangent is negative. All right, so let's look at this. So we need to go ahead and find our x, right? Because we know that y is equal to 2, r is equal to 3. So therefore, I have r squared is equal to x squared plus y squared, right? Therefore, I can go ahead and plug this in, so it'd be what? 3 squared is equal to x squared plus, and my y squared would be 2 squared. So basically, I got 9 minus 4 is equal to x squared. So that would be 5, and that'd be x squared. So x is just equal to the square root of 5. Now, we know that it's negative, so we're going to use the negative square root of 5. Now, since we have that, we know that x is equal to the negative square root of 5. So now we can go ahead and find everything we need. So we need to find cosine of theta. We need to find tangent of theta. We need to find secant of theta. And we need to find cotangent of theta. Now, cosecant of theta is equal to what? 3 over 2, because we already know sine of theta, right? So therefore, so we got cosine is equal to what? The negative square root of 5 over 3. Then we got tangent is equal to what? 2 over the negative square root of 5, which that equals what? Negative 2 times the square root of 5 all over what? 5. Let me make that look a little better. All right. Now we have what? This is equal to what? Negative 3 over the square root of 5, which is secant of theta. Now, when I do that, this will just be what? The negative 3 times the square root of 5 over 5. That's when you rationalize it. And then my cotangent of theta should just be negative square root of 5 over 2 because the reciprocal function of tangent. So just make sure the negative comes from the quadrant that you're in. So we know in quadrant 2, cosine is negative. So my x is a negative. And that affects what? Tangent and cotangent and secant. So just keep that in mind. All right. Now, Pythagorean identities. It says for all angles theta for which the function values are defined, the following identities hold. Now, it says sine squared theta is plus cosine squared theta is equal to 1. Then we have tangent squared theta plus secant, plus 1 is equal to what? Secant squared theta. Then we have 1 plus cotangent theta is equal to cosecant theta. Now, there's always alternative ways you can write this, but we're going to just stick with these right now. And these are your Pythagorean identities. You have to use these a lot. So make sure you understand what you're doing. So it says for all angles theta for which the denominators are not 0, the what? Following identities hold. Sine of theta over cosine of theta is equal to tangent, kind of like your x over y. Your y over x. And then cosine of theta is cosine theta over sine theta is equal to cotangent of theta, which is your x over y. All right, so keep that in mind. So we're going to use these as well. So find sine and tangent given that cosine of theta is equal to the negative square root of 3 over 4, where sine is what? Greater than 0. All right, so sine is what? Positive. So let's do this problem. So I can easily find, so I know that what? Sine squared theta plus cosine squared theta is equal to 1. Therefore, I know that sine squared theta plus negative square root of 3 over 4 squared is equal to 1, where sine squared theta plus, and it's going to just square everything in here, so it's going to be what? 3 over 16 equal to 1. Therefore, sine squared theta is equal to 1 minus 3 over 16. Now, me personally, you change 1 to 16 over 16, then you should try it, right? So you got sine squared theta, and then you'll get what? 13 over what? 16. Then you take the square root of it. So you get sine theta is equal to what? The square root of 13 over what? 4. Now, we already know that it's positive, so that we're going to keep it positive. So you don't have to put plus or minus. So keep that in mind. All right? We know that sine is positive, so we will keep it as the square root of 13 over 4. So I don't have to put plus or minus. Now, to find tangent of theta, we don't have to go through all that work. We know that is what? Sine, which is 13 over 4, divided by cosine, which is the square root of 3 over 4. Well, negative square root of 3 over 4, right? Therefore, it would be the same as me writing the square root of 13 over 4 times 4 over, well, negative, square root of 3. Therefore, the 4 is canceled. So it's the square root of 3, the square root of 13 over what? The square root of 3, and that's negative. Now, remember, you got to rationalize it, right? So you will get basically what? Negative the square root of what? 39 over what? 3. Because you're going to have to multiply this by the square root of 3 over the square root of 3. All right? And when you do that, you can multiply things inside the radicals, and then you will get square root of 39 over 3. And it's going to be negative. And it's supposed to be negative because we're dealing with cosine being negative and sine being positive, which that should be what? The second quadrant. Make sure if you have any issues with this, you let me know. So this says find sine theta and cosine theta, given that tangent theta is equal to what? Is equal to 4 over 3. Now, with that being said, let's go ahead and find what r is. So r equals the square root of 4 squared, which is what? Well, I'll do 3 squared, which is 9 plus 16. All right. So it's equal to what? The square root of 25. So r is just equal to 5. Right? Now, we know it's in quadrant 3, so that means that they both are what? Negative. All right? So we know they both are negative. Quadrant 3 tells me that both sine and cosine are negative. All right. So when I do this, I'm trying to find sine. So sine of theta. Now, honestly, you know you know everything you got. So you don't have to go through all the extra stuff. And I know it says using, so what we're going to do is, we know we could use the fact that, we know we can use the fact that we know what x and y is, right? So what they want you to do, all right, is use the Pythagorean identities. Now, I went ahead and found r, all right? I wanted to find r because I wanted to be able to check myself. So you got to make sure you do what they have to tell you to do. So now what they want you to do is, it says take, so we know that we have tangent squared theta plus 1 is equal to secant squared theta, right? Now, that means I have what? 4 over 3 squared plus 1 is equal to secant squared theta. Therefore, I got 16 over 9 plus 1 is equal to secant squared theta. Therefore, I have what? 25 over 9 is equal to secant squared theta. And then I take the square root of both sides. Then I know I'm going to get I'm going to use the negative. So I'm going to take the square root. So it's going to be negative 5 over 3 is equal to secant theta. Now, I know that this is the reciprocal function of cosine. So I know that cosine of theta is just equal to the negative 3 over 5. Now, could have found that easier without doing all that, because I already knew what I had here, which was my x over y, but I know that both was negative from the get-go. Now, since I have my cosine, I can say that I got, and I'm going to change colors so nobody won't get confused on what we're doing. So I know that the what? Sine squared theta plus cosine squared theta is equal to 1. So I got sine squared theta plus negative 3/5 squared is equal to 1. So I got sine squared theta plus, and I got 9 over 25 is equal to 1. Then I'm going to subtract that to the other side. So I got sine squared theta is equal to 1 minus 9 over 25. Therefore, I have what? Sine squared theta is equal to what? 16 over 25. Then I take the square root of both sides. And it's equal to what? Negative 4 over 5. Now, we use the negative 4 over 5 because of the fact that we're in the third quadrant. That's the whole purpose of using it, because we're in the third quadrant. So make sure if you have any questions about anything that we went through in 5.2, you let me know.